Hey, what's up? It's your old pal, Mr. Cook. We're going through this review. Got through the first four problems. Now it looks like we're on the physics problem. Okay, so the physics problem. A particle moves along a line such that its position is given by that equation over there. S of t is equal to 2t to the third minus 5t squared plus 2t. So we got to justify all our responses as we're going through this. Part A asks you to find the velocity of the function. So let's go ahead and answer it. Let's see here. Zoom in so we have a little bit of space here. There we go. All right, so the function was, let me put it as reference over here. All right, so 2t to the third minus 5t squared plus 2t. Okay, there's our position function, s of t. So velocity is going to be equal to the derivative of position, and this is justifying my answer. So if I take the derivative of the function, that'll give me the velocity function. So using the power rule straight across, I get 6t to the second power minus 10t and then plus 2. All right, what is the velocity after 1 second? So all you got to do is just plug in 1 for this one. So we get 6 minus 10 plus 2, so negative 2. And then let's see, does it have units on it? I forget. Meters and seconds, so meters per second for this one. Don't forget units when you are answering word problems. Oh, did I forget to put units on the poster? No, I think I put inches on that. Okay, we're good. Find the acceleration at time t, easy. So acceleration is equal to the derivative of velocity. So we just take the derivative of the velocity function that we got in part A. That'll give us part C. So using power rule again, we get 12t minus 10, and there's our function. Find the acceleration of a particle at time t equals 4. Okay, so we just plug in 4. A of 4 is going to be equal to, and then it'll be 12 times 4, which is 48. 48 minus 10 is 38. And then now it'll be in terms of meters per second squared, because those are the units for acceleration. When is the acceleration of the particle? 0. This is pretty easy too. We just set 0 equal to the acceleration function, which is 12t minus 10. And then we just solve for t. So, adding 10 to both sides and then dividing by 12, we should get t is equal to 5 over 6. And the units for that are going to be seconds, because it's an amount of time that we're solving. All right, next, when is the speed of the particle 1 meter per second? Well, that word speed is actually pretty important to know in position values, because speed is kind of like velocity, but without any direction. In other words, like without a sign. It's the absolute value of the velocity function. So when it asks for a speed of the particle of 1 meter per second, it's also asking for, negative 1 meter per second. It doesn't really say that, but that's what it's implying. It's implying that, the velocity is equal to both of these values. So, that's when we would just use the velocity function and solve. So here's our, velocity function from a second ago. So we would set it equal to 1. 1 is equal to 6t squared minus 10t plus 2. And then, you solve it. And the best way to do it would be to probably use your calculator. Does it also say over an interval or anything? When speed of the particle? No, it doesn't really. So negative numbers could technically apply for this. So let's solve for t. So I'd probably subtract 1 from both sides. 0 is equal to 6t squared minus 10t plus 1 now. And then I would use quadratic formula if I was doing this by hand. But I'm allowed to use my calculator. So let me show you how to use your calculator to do this. So just type in the equation, 6 and then x squared minus 10x, then plus 1. And then just use your calculator. So there's a couple different ways to do it. I like using the 0 function. So I go to second and then trace, and that brings up this calculate menu, and I pick the second option, 0. So when it graphs out my equation, right, I just look for the zeros where that happens. So it looks like there's going to be a 0 right here, and then another one right here. So I'm going to use my calculator to find that. The first thing that I do is I pick a spot, and I can use the left and the right cursors on my calculator to kind of work through, move through the graph. And I pick a spot that's to the left of where the 0 is on the x-axis. So that's the spot where I would pick right there, maybe to the left. And then a spot that's past where the 0 is. So right there. And then that's my right area. And then I hit enter and then guess. It doesn't matter where you guess, because it'll just give you a number where the 0 is. So it looks like one of my zeros, and therefore one of the times where the velocity is going to be equal to 1, and therefore the speed is equal to 1 meter per second, is going to be when time is equal to 0.1069 seconds. You only need to round to 3 decimal places. I like to round to 4 just in case because it gives a little bit more accurate answer. Okay, let's find the other 0 because it looked like there was a second one in there. So we just do it again. Second, calculate, and then, second, calculate, and then 0. All right, so I need to go to the left on the x-axis of the y value, or the 0 value there, and then go to the right of it, so past where the 0 is, like maybe right there. Then hit enter one more time. And that gives me the other t value, 1.5598. And of course, that's in terms of seconds. Okay, keep going. So next up is going to be when the velocity is equal to -1. Because remember, even if it has a velocity of -1, the speed is still 1 because speed, it doesn't have direction. So negatives don't apply to it. It's the absolute value. Okay. And then if we add 1 to both sides, we get 0 is equal to 6t squared minus 10t plus 3. And again, just use your calculator to find those zeros. So y equals, looks like we just got to change that last number to a 3 now. And then we just repeat the same process. You can fast forward through this if you want. It's just the same thing. So let's see. First 0 is there. So we got to do to the left and then to the right. And just guess. So our first number is going to be 0.3924 seconds. And then our second number is going to be, let's see here, calculate 0. And let's go here to the left and then over here to the right. And guess. Our next number is going to be 1.2743 seconds. There you go. So those are all the different times where the speed is equal to 1 meter per second. Next, at what times in the interval from 0 to 8 is the particle changing direction? So the particle is changing direction when the velocity goes from positive to negative or negative to positive. So that's just something that you got to kind of like remember. When it's talking about changing direction, it's when the velocity changes signs. Okay. Oops, I'm sorry about that. Let me zoom out a little bit. There we go. All right, so let's go to our calculator for the velocity function. And what we would do is we'd find the zeros where this happens, and then, just like determine where it goes from positive to negative, essentially. So let's change our graph over to the original velocity function, so +2. And then when we graph it out, it looks like this. And let's zoom in a little bit, okay? So I'm going to zoom in a little bit on my graph. All right, so what I'm saying is that, this is the velocity function. All of the spots that are like above the x-axis, that's going to be where the particle is moving in the positive direction. Maybe it's moving to the right. So these two spots are where the particle, is moving to the right. And then the spots that are below the x-axis, like right here, that's where the particle is going to be moving to the left. So in between those two spots, that's where the particle is going to be changing direction. So those are the ones that I'm interested in, the zeros. Because outside of those, that's where it's going to be, going in opposite direction. So I'm looking for those two t values. So again, I'm just going to use my calculator and find those. I'm looking for the zeros. So from my graph, let's find them. So graphing calculator, here we go. Oops. 0, and then let's see. There's a number that's to the left of the 0, and then to the right of the 0. So here's our first place where it changes direction, 0.2324 seconds, 0.2324 seconds. Okay, and then the next spot that it changes direction is, again, the other 0. So I got to find that as well. So let's go to the left of that 0, maybe like right here-ish. Then to the right of the 0, so past the 0 right there. Then enter again. And there's my other place where it changes direction, going from a negative velocity to a positive velocity. That'd be 1.43. Okay, so 1.4343 seconds. Okay, and I guess I better start justifying some of this stuff. So at what times of the interval that? Well, it's these, because when I graph it out, right, like those are the locations where it changes from a positive velocity, both of those, to a negative velocity. So at those two spots right over there, it changes direction. And I could write a sentence about it. This is where it changes direction. And then when the particle is at rest, that's when the velocity is equal to 0. And I just found those points. So it's like the same ones. It's at rest technically for a moment, and that's it, just that one instance, and then it's different. Okay, last couple. So is the particle moving to the right or the left at time t equals 4 and at t equals? Okay, so if it's moving to the right, that means that it has a positive velocity. And if it's moving to the left, it has a negative velocity. That's it. So we just have to plug those numbers into the velocity function. So v of 0.4. And let's also find v of 1.5. All right, let's plug it on in there. So let's go to table setting, independent, ask. Because we already have the velocity function in there, so let's just calculate the value from our table. All right, so if I plug in 0.4, what do I get? Looks like negative 1.04. So negative 1.04 meter per second. And then for 1.5, I get 0.5, so 0.5 meters per second. And since this is negative, the velocity is going to be, since the velocity is negative, this is going to the left. And then since the velocity is positive here, I'm going to move into the right. And I'd write like a little statement about that as well, just to kind of show why it's the case. Okay, next. At those same times, is the particle speeding up or slowing down? So if a particle is speeding up, that means that the velocity and the acceleration have the same sign. So they're either both positive or they're both negative. If the object is slowing down, it means that the velocity and the acceleration have different signs. So one of them is positive and one of them is negative. So we've already found the velocity for those times. The only thing we need to find is the acceleration. So the acceleration at 0.4 and the acceleration at 1.5. So I'd use the acceleration function that I found a little earlier. Where is that? Here it is. So this one. Okay. So I use my calculator for that as well. I could probably just plug that in, type it in. 12 times parentheses 0.4 and then minus 10. Okay, so one of them is going to be negative 5.2 meters per second squared for acceleration. And then the other one is 12 times parentheses 1.5, then minus 10 again. 8. So that's a positive 8. So 8 meters per second there. So since both of the accelerations, the acceleration and the velocity at time t equals 0.4, both of those are going to be negative. So that means that this thing is going to be speeding up in the negative direction. And then since both of these are positive, the velocity and the acceleration, this is also going to be speeding up, but this is going to be going in the positive direction, to the right. Okay, so that's all that you need. That's number 5. My gosh, that was a lot of stuff. So that's the end of this video. On to the next one. See you later.